Let's get going. So as we look at integrals of exponential functions, we think about the derivative, right? And the integral is the opposite of taking the derivative. So if the derivative of e to the x is e to the x, then the integral of e to the x is e to the x. But we remember that we have to do plus c because it can be a whole family of functions. And so here is what we're looking at. So we're just going to do some examples today of finding these integrals. So when we look at this, we have e to the u times du. So we have to make sure that whatever this u is, that du is present in our integral. So here we can let u equal 3x minus 1. And that would make du equal to 3 dx. And this is the same kind of trick we've been doing for the last couple weeks. So we see the dx is here, but we don't have a 3. So we rewrite this integral as 3 e to the 3x minus 1 dx. And when we multiply by 3 inside, we're going to multiply by 1/3 on the outside. Okay. Now you can see that this is in the form 1/3 times the integral of e to the u du. Okay. So everybody catch that 3 dx turns into du? It's the same thing there. And now we're just going to follow our integration rule here. So we get 1/3 e to the u plus our constant. And then we're going to substitute u back in for our final answer. So 1/3 e to the 3x minus 1 plus our constant. Okay. So again, just follow the u throughout this problem. We have 3x minus 1 there. It stays there, becomes u, and then we change it back at the end. Okay, and the 1/3 right here was the result of negating or countering the 3 dx. All right, so for letter B, what should we let u equal? Negative x squared. Okay, and so du, negative 2x. Okay, now when we look at our function, I do see the x right here, but we're missing the negative 2.
When I have du equals negative 2x, do I have to put dx behind that or no?
Oh yes, we should have negative 2x dx. Okay, so we're going to do a couple steps here at once. We're going to take out the 5, because we know the constant multiple can come out. Okay, we're going to change it to negative 2x on the inside. So we're multiplying by negative 2, which means we have to multiply by negative 1/2 on the outside. Then we have e to the negative x squared dx.
Mr. Paul,
Mm-hmm.
you know what someone showed me too was they did u and then du, which equals negative 2x dx,
Mm-hmm.
and then they solved for dx,
Mm-hmm.
so they got du over negative 2, is it x? Yeah, negative 2x, and then the x's would cancel out with the x and the 5x, and then still you would 5 over 2 e to negative, so that's just not a big deal.
Yeah, so you still have negative 5 over 2.
Yeah. What's someone showed me?
Okay. Connor?
I think this is what we last time.
You need a worksheet? You need to put that away. It's not the appropriate time to be texting. All right. So going on from here, we can just rewrite this, clean it up a little bit. We're going to substitute in u and du. So we really have e to the u, du. So now we can integrate -5/2 e to the u plus c, and then substitute u back in. And there we go. Any questions there? Andrew, did your way work out?
Yeah.
Okay. All right, moving on to the letter C. Okay. So let's just keep trying this. We have our exponential function. So we'll let u equal 1/x. And let's go ahead and find du. And so we have -1/x squared dx. And so in my integral I can see 1/x squared, but I don't see negative. Okay. So we're going to have to add the negative on the outside and on the inside. And then I can rewrite this using u and du. Okay, and that's probably the trickiest step there. So it's just seeing the u getting replaced, and then finding all the bits of du. So -1/x squared dx just changes into du. All right, and the integration is fairly easy. -e to the u plus c, and then simply substitute u back in. Moving on. Letter D. Here.
It makes more sense when you highlight it. That helps a
You like
lot.
that?
Yeah.
It's because otherwise, like, you got all the pieces everywhere.
Yeah, but that helps a lot.
Good. All right. So here we're going to let u equal cosine x. Okay.
Now you just have to get everyone else highlighters.
I need what?
So now you just have to get everyone else highlighters.
Oh yeah. You can bring your highlighters.
50. Just one and a half.
Derivative
No,
of
no,
cosine.
Sorry.
Negative sign.
That's not bad.
Sorry, you were rambling, so
I know.
I'm going to cut you off
Apologies,
now. Okay, so you can see up here we already have the sine x, but we're missing the negative. So we're going to put the negative on the outside, the negative on the inside. Oops, don't forget the dx. So here we can see du. And of course, our u is still there. And this step, you know, it's really just, if you have trouble visualizing it, you could go straight to this. Or you could even skip this step and go straight to the integral. All right. Any questions so far? All right. We're going to keep getting a little more complicated here. So when you have a numerator here that has multiple terms, this is something we've been looking at a little bit, is breaking this up into two integration problems. Okay, and that's going to be helpful because if we had let u equal 2x, the derivative is 2, but we still have too much here in the numerator. So it really wouldn't have worked out this way. So what we're going to do instead is integrate each one separately. And I think we're going to go ahead and get rid of the fraction type of idea here. I'm going to take out my constant multiple if that's okay. And I'm going to write e to the negative 2x. It's going to be a little easier to work with. Here I'm going to take out my constant multiple of negative 1. And I'm going to go ahead and use my rules of exponents here to rewrite this as e to the negative x. Hello, sir. Did she get taken last time?
Yeah.
It's real random. All right. So we'll just do these separately here. So we see that for the left one, u would equal negative 2x, and du would be negative 2 dx. Because it's negative 2. And so we can rewrite the left integral here. 5 times negative 1/2 times the integral of e to the negative 2x times negative 2 dx. So you can see our u here, and then you can see our du. I'm actually going to go ahead and just integrate this. Can you see u du? So we're just going to go e to the negative 2x for that one. And then for the right side,
That is integrated?
yep, that's integrated. I just didn't rewrite it e to the u du, because you can start, going straight there. Okay, for the next side, u is negative x, du is negative.
Plus C at the end then.
What's that?
You just do plus C at the end.
We're going to do plus c at the end, because if we add two constants together, we still have a constant. So here we just have to add a negative in. Okay, so if we already have a negative out in front, and we need to multiply by a negative, it's just going to change it to a positive. Good. Okay, so you can see your u here, and then you can see du. And we can go straight to integrating this as plus e to the negative x, and then plus c. All right. Moving on. Are you okay with this?
Wait.
Okay, now the definite integral. So we're just going to find the indefinite integral and then evaluate it using the fundamental theorem of calculus. Okay.
E to the 0 is 1.
Okay, so you can see we're just missing negative there. So can you start going straight to the integral?
Yes.
Yeah. So it's going to be negative e to the negative x. We're going to evaluate this from 0 to 1.
So it's just negative e to the 1 over negative e. Yes.
So negative e to the negative 1 minus negative e to the 0.
Which is negative 1.
Good. We'll just swing the e to the negative 1 under the denominator.
It's a number function. I don't think it's doing like that.
We'd probably, not leave it double negative.
Well, plus a positive, yeah.
Right, so we'd probably change it 1 minus 1 over e. And we are going to get an approximation here. So 1 minus 1 divided by e. And of course you got to put to the first power here to just be e. Okay. Let's move on to letter G.
Would you make u x or would you make u 1 plus e to the x?
Okay. So those are our two options, right?
Yeah.
So if we let u equal x, du is
1.
1. Okay.
You just fill in that 1 right there.
But it needs to be a factor of 1.
Yeah.
And I don't see, we have a factor of 1, but then there's extra stuff down
Yeah.
here.
So we should make 1 plus.
So
Mm-hmm.
You could do quotient rule, but the easiest way, like you guys have already said,
Whatever u.
is don't forget what we've been doing the last couple days. Let the denominator equal u. And sometimes that's a good thing to always check, because now du is e to the x dx.
How do we change A and B?
So this is 1 over u.
E,
So here's our u.
we need to change the variable
And here is our du. And if you look at this original function, we don't need to alter it at all because I see du right here.
Don't we need to change the numbers though? The 0 and the 1, the B and U?
We'll get there.
Yeah. We have to change the 1 and 0.
What?
It could be used as position.
Okay.
That's only if you leave it u. If you put it back in, it's 1 plus
That's
u.
true.
So we'll just stall for a moment on our definite integral.
Sure.
Okay. And then what is the integral of 1 over u du?
Is it the natural log thing?
Oh, so that
Natural log of u.
wait, why did you make it 1? Use,
So do you see du is e to the x times dx?
yeah,
E to the x times dx.
so just 1.
Yeah. You could have also written this as u prime over u. It's the same thing. So we see it's natural log of u. Let's go ahead and substitute u back in here. So again, u was 1 plus e to the x. And we want to evaluate this from 0 to 1.
Because you're not putting any
Plus.
And I think in this situation, because we had nice numbers like 0 and 1, and also the integral with u was very simple, it's better just to substitute u back in.
Yeah.
Okay? So
What's 1 plus B over 0? 3 equals
0.
Yeah. It's 1 plus E to the 0, which is 0.
E to the 0.
But it's 1. It's minus the 1.
Okay. So we get natural log of 1 plus e minus natural log of 2. E to the 0 equals 1. Anything to the 0 power is 1.
Well, there's a 1 over there.
Yep, I mean, 6 to 0.
We do get 0.620. Okay, so just because there's an e doesn't mean we don't forget about natural logs, especially when we have fractions here.
Aren't most logs natural? I haven't seen any synthetic
All right, and for letter H here, we don't see anything funny. -1 to 0, so that's going in the right order. We have e to the x times cosine e to the x.
Let's make it u e to the x.
Good. So a lot of times, when you have your trig functions, you're going to let this part, whatever you're taking the trig function of, equal your u.
Oh, those cancel out.
It's a very common thing. And then the cool thing here is when you find du,
Which is cosine e to the x. No, it's
we just have e to the x dx, which you can see is already a part of the original function.
It seemed to go up cosine, but it's sine of this.
So the integral of cosine is
Uh,
sine, because the derivative of sine is cosine. Okay? So here,
It's a chamber, right?
alright, same way when we evaluate this, sine of e to the 0,
Sine 1 is 0.
minus sine e to the negative 1.
Wait, don't we get the chain rule though? No. E to the x? Because you have, or not?
So the derivative of e to the x is e to the x
Yeah, and those
dx.
cancel out, cool, but I guess when we derive the sine e to the x, do we have to divide by e to the x because that's the derivative of the inside?
Well, this becomes, we could rewrite this then as
Sine e to the x.
cosine u du.
But and then we have to integrate that.
Right.
Which is sine u times u, or times 1.
No? So if we have the integral of cosine u du, since du is already there,
Right, it's sine u times 1.
no, when you're integrating, you don't multiply.
Oh.
Chain rule only applies with derivative.
Brain
I know what it is.
scrambled.
All right, and that should give you enough time to calculate this.
Wait, 482?
0.482.
Yeah.
Wait, you're going today or
No,
no?
no.
Today you have an 8.
Yeah, no, I'm running dirty.